approach this particular problem. Okay. So let's say an array is given to you, and array is 3, 5, 4, 2, 8, 1, 5, 6, 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 4, 5, 6, 7, 5, 6, 7, 8, 9. And let's take one more number as 3. Cool. Now, let's say this array is given to you. Now you need to, you can perform a bunch of operations on this array, and you need to return. So there are a few queries given to you, and based on the queries, you need to either return the sum. So let's talk about the queries given to you. So the queries are like this. The first query is to return sum from L to R. So basically from the Lth is the index and R is also the index. Okay. So you need to return, L represents the left index, R represents the right index. So given the indexes, given the from and to indexes, you need to return what is the total sum in the current array. The second query can be update query, where you go and update a particular number, update a number in the given array. Correct. And there can be multiple queries like this. Okay. Multiple queries. So for each queries, you need to perform some operation. So in this particular query, you need to return print the answer for the sum from L to R, and in this you need to update. So basically this is your read query and this is your update or write, whatever you want to call it as update query. Okay. Now, typically how you'll approach this problem is, so there are multiple ways to approach this particular problem. The one way is to actually go every time. So let's talk about the different ways. So way 1, okay, or solution 1. It's fairly simple. What do you do is every time you run the loop from L to R, okay, and calculate the sum. Correct. So this particular print operation will become, or first query will become of the order of n. And the second operation is update operation, where you go and update the value. Because it's an array, you can directly go onto the index and update the value. So the operation will become order of 1. There is a second approach which you can follow to solve this particular problem. What you do is you actually take the sum of all these numbers and keep it in this array. So let's say here you have 3, so you put 3, then 3 plus 5, 8, plus 4, 12, plus 2, 14, plus 8, 22, and so on. Correct. And so you maintain this sum every time. And when you need to return the sum from L to R, what do? You directly go to that particular Lth index, you go to Rth index, and you do L minus, if you want to find the sum from L to R, correct? So 5 plus 4, 9, plus 2, 11. So you go to the previous index of the L and subtract that value from the Rth index. So you'll get the sum from L to R. So the operation will be order of 1 in this case, but your update will become order of n. Update will become order of n because let's say you have changed this particular index. So what do you have to do? Let's say 1 became 5 now. So what you'll have to do is you'll have to actually add 4 in from here till here in all the indexes present in your sum array. Correct. So again, the update operation in the worst case can be up to order of n. So these are the two ways, simple ways to solve this particular problem. Now the issue is that both the operations are worst case, both the solutions are giving us the solution in. So basically, both the ways are giving us the solution in order of n. Now, let's say if we want to optimize this particular approach, then how can we optimize the solution for the given question? Then how can we approach this particular problem? So instead, what if I tell you that there is a way to do both the operations in log n? So there is way 3 where I tell you that both the operations can be performed in log n time. So your update as well as your read is performed in order of log n. So which one would you prefer? Now again, it depends on the kind of question, it depends on the question given to you, right? So see, if you know that like only once you have to calculate, so you don't have a lot of read, like let's say you just have one read and you have lots of updates, correct? Then maybe you can prefer this approach. If you have lots of updates lots of read, but there is only like a 1 or 2 update, then maybe you can follow this approach. But if I tell you that the weightage to each of these queries is almost same, then what would you like to do? Would you prefer any of these two approaches, or would you go for order of log? See, in this case, because the overall complexity to perform each of these operation is order of log n, you'll end up preferring order of log n. Why? Because let's say you have n operations of order of 1 and 1 operation of order of n, then your overall complexity here in this case will become what? Order of 1 into n plus order of n, which is equal to order of n. I'm just trying to explain you how it works, how the complexity works, and when should you actually go and follow approach third approach, correct? Let's say the number of queries were m, correct? So your overall complexity will become order of m plus n, which is, let's say, approximately equal to order of n. Here in this case, again, let's say you have lots of just one update, so order of n plus lots of reads, so order of 1 into m, so it will again become order of n plus n, correct? Now, in this case, if there are equal number of reads and update, it will be m log n plus m log n, so it will become m log n. Now imagine that you have lots of reads as well, right? So here what will become order of n into m plus order of 1 into m, so it will become order of n into m. So similarly, this will also become order of n into m. In the worst case as well, this is the best case scenario which we are taking, correct? This is the worst case scenario which we are taking. Here in the best case as well as in worst case, you will always get m log n. M is the number of queries and n is the number of elements you have in your array. So it will be order of m log n in the worst as well as best case. So that's why if you know that the query, I mean, you need to optimize your solution based on the given queries, then you should go ahead with this particular solution. And now, to understand how can you do it in order of m log n, we will try to understand what is segmentary. Okay. So let's talk about segmentary now. I just give you the background of how to determine whether you actually need to go with the segmentary or not, and how to take a call whether, like, which of the following approaches are the best approach to follow for a particular problem. So let's talk about segmentary now. Okay. So what do you do with segmentary? Let's take some elements. Let's take 1, 3, 5, 7, 9, 11. I'm just keeping it small right now, just to so that it becomes easier to explain you how to create a segmentary. So first, let's try to understand how segmentary is created. Okay. So what do is you simply put all the nodes, create all the nodes at a leaf level. Okay. And this is my 0 index, this is my first index, this is my second index, this is my third index, this is my fourth index, this is my fifth index. Correct. Now what you do is, the indexes are from 0 to 5. You always calculate the mid. So what is the mid of 0 to 5? That is 0, that is 2. So I'll break this 3 into 0 to 2th index and 3 to 5th, third to 5th index. Okay. Now again you take out the mid of this. What is the mid of this? It is 1. So again you break this out into 0 to 1 and 2. Correct. Similarly you break. So these are the indexes. Okay. And similarly you break this down. So this will become 3, 4, and this will become what? 5. Now what you do is you create this and add it here. Because again 0, 1, 1 can be divided into 0. And now what you do is you add the value of these. These are your leaf node, you put here, and you mention here that this is my sum from 0 to 1. Okay. Similarly, what do you do here? Now you know that this and this can be merged from this tree structure. So we merge these two values and we say that this is my 9 from what? From 0 to 2. Okay. Similarly, you merge these two values. This becomes what? Your 16, and 16 plus 11 will become what here? It will become 27. Correct. So this will be from 3 to 5. This will be from 3 to 4. And then finally you have addition of everything, which is 0 to 5. And the sum is basically 27 plus 9, which is equal to 36. Okay. Now, did you understand how I created this tree? And if you have any questions, then please ask. Otherwise, I'll move forward from here. Wait for like 20 seconds. Cool. Now, considering everything.
Is it like
Yes.
we tried to divide the tree in sort of binary search, and again we merged back and calculated the sum?
Yes, not binary search. You can call it as binary tree, not binary search tree. It's not a search tree, right? The numbers are not sorted in a way. So basically, okay,
Oh,
the numbers are sorted here, but it's not necessary. And you can sort 3 and 1.
oh, okay.
It's
Thank
not a
you.
binary search tree. It's a binary tree.
Okay,
Exactly.
okay.
Uh,
Thank you.
uh, can I ask one question, sir? What is this? That it's a bottom-up approach. I can see. I don't have that much depth knowledge in data structures, but whatever tree I have read so far, all of them were top-down. So I don't know how to write the code to create this kind of bottom-up kind of tree.
See, the thing is that don't worry about all those things right now. Try to understand whatever I am explaining to you right now, and then we'll jump onto the code part as well. I'll help you to understand as well as write the code right here in the class. We'll write the code for this one. Try to understand whatever. So if you have any questions related to whatever I have
No,
taught
no,
you,
no. That thing I got that.
feel free to ask. If you don't have any questions, then wait for, don't worry, I'll explain you the complete solution as well, and how to approach and how to write the code for these, for the segmentary as well. And I'm pretty much sure that after this class, you'll be very comfortable to write the code for segmentary. So don't worry about that, okay? Wait for that. Try to understand whatever I'm trying to explain right now, because if we'll jump onto that part, then like we'll lose some time, and then it will be difficult for me to complete everything within like next 1.5 hours. Okay, cool. So if you don't have any questions, then it's fine. If you have any questions regarding whatever I've explained so far, then we can discuss that. Okay, cool. Now, so I can assume that there is no other questions related to whatever we have discussed so far. Now let's try to understand how to create this tree and what should be the size of this tree. See, again, just to explain you, segmentary is also represented as array. Correct. So whenever you have to create a segment tree, you will end up creating an array only. This is just to understand how segmentary works. We can create a tree, but if you have any problem, or if you are solving a particular problem which is related to segmentary, then you will end up creating an array for this particular segmentary. Now, how to fill the data in this array is very, very important. Okay, because as someone mentioned right now, they've always seen the top-down approach, not the bottom-up approach. That's where and exactly that's why it's very difficult to create a tree from the bottom-up approach, and that's why we have a array representation. Okay, now let's try to understand how to create the tree. So let's say this is my index. Okay, this is my 0th index. Consider this is my 0th index. Everything is stored in the 0th index. Okay, the total sum is stored at 0th index. Now what do you do is, always the left child in a binary tree, consider this is my tree. Okay, the left child, and this is my index. Correct. In an array, the left child can be represented as 2i plus 1, and the right child can be represented as 2i plus 2. Considering it's a full binary tree, basically a full binary tree is a tree in which all the till the last level, all the elements are filled, and every node has 2 child, and the leaf nodes has 0 child, no child. Okay, so considering that, this will become my 2i plus 1 index, and this will become my 2i plus 2 index. So can I say that this is my 1 index, this is my 2 index? Now this index will be my 3rd index, this index will be my 4th index as per our definition. So this is like 2i plus 1. What is the parent? 1 is the parent. 2 into 1 plus 1 is 3. So this is 3rd, and this will be 2i plus 2. So this will become what? Index number 2 into 1 plus 2, which is equal to 4. So this is my index 4. Similarly, this is my index 5. This is my index 6. This is my index 7. This is my index 8, and so on. Okay. Now let's try to see how to create a similar tree with the help of this approach. Okay, so what do we have right now? We have index from 0 to 5. That is all we know so far. And okay, is my voice audible, or is it breaking? Can you hear me clearly?
Yes, brother.
Okay, cool, thanks. So now let's try to understand how this particular tree has to be created and how it has to be represented in the array. Okay, so as I mentioned, we need to go up with the bottom-up approach. So what we'll do is we'll create an array. Let's assume there is some size of array right now. I won't disclose the size right now because I want you guys to understand it completely, that why the size of the array is this much. So let's put some indexes here. Okay, let's make it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. We'll see if we need more. Okay. So now how many elements do we have? We have 1, 2, 3, 4, 5, 6 elements. So let's create, let's have these 6 elements here. So the 6 elements are 1, 3, 5, 7, 9, and 11. This is my index number 0. Correct. So my index number 1 in the array, 2 in the array, 3 in the array, 4 in the array, and 5 in the array. Correct. Now what do we do? So every time, so this is my what? This is my array which is given to me. Correct. And this is, can I call it as, this is my segmentary array, STA. Okay, this is my segmentary array, this is the array given to me. So what I'll do is, I know that there are total how many? 0 to 5, correct? So I start with 0 to 5. Okay, now I break this down. Now this, if I break it down, I find the mid is 0 to 2. Correct. This is my 0 to 2, and this is my 0 to, sorry, 3 to 5. Correct. So whatever data, so this is my, consider this is my index 0. So considering this is my 0 to 2, the index will be 2 into I plus 1, which will become 1. So 0 to 2. So I'll write it here. So for the data which is from 0 to 5 will be stored at index number 0. The data from 0 to 2 will be stored at index number 1. And the data from 3 to 5 will be stored at number 2. Okay. Now again, I break this down. If I break this down, this will become what? 0 to 1 and 2. Correct. Now this is my index number 1. This is my index number 2. Now what is this my index? What is this index? This will be 2 into I plus 1. So this will be 3 and this will be 4. So whatever data is from 0 to 1 will be stored at index number 3, and whatever data is there here of 2 will be stored at index number 4. So basically, can I write just of index 2? Correct. Now I can further break this down. This will become what? My index 0. So just 0, and this will become my 1. So this will become what? 3 into 2 plus 1. So what is 3 into 2? 6 plus 1, 7. So at 7th index, and 3 into 2 plus 2. And at 8th index, I'll store the data which is at 7th index, I'll store the data which is related to 0. And at 8th index, I'll store data related to 1. Correct. Similarly, at 4th index, I'll store, as I mentioned here as well. Correct. And this can't be further like we can't break this further. So we'll stop it here. Now from 3 to 5, this is my index number 2. I can break this into, I'll find the mid is 3 plus 5 by 2, which is 4. So I'll break this down into 3 to 4 and 5. Correct. Now what is the number? Index number 2 into 2 plus 1. So this will give me index number 5, and this will become 2 into 2 plus 2, which is equal to what? 2 into 2 is 4 plus 2 into I plus 2. 2 into 2 plus 2, which is 6. So at index number 5, what I'll store? I'll store the data from 3 to 4. And at index number 6, I'll store the data for. So this represents these indexes, okay? This represents these indexes: 5, 4, 3, 2, 1, 0. 0 to 5, everything will be stored. The sum of this complete will be stored as a part of this. Okay. Now this can't be further. We can't break this down from here. Understanding calculation of 2i thing like assuming indexes. Okay, got it. I'll explain you how to assign the indexes. So basically consider, let's try to understand this assigning of indexes again. Okay, I'll come on to this again. Let's see this part. Small, very small, simple thing. Okay. Let's say you have this tree. 1, 2, or if you would have, and if anyone of you already know heap, then it will be easier. 4, 5. Correct. Now, if you have to represent this tree in an array, so what do you do is at 0 index you put 1. Correct. At 0th index you put 1. And what do you tell is I'll store. I know that my child of this one is 2i plus 1 always and 2i plus 2 always. So whatever is my current index, this considering this is my 0th index, at 1 I'll put 2, and at 3 at index 2 I'll put 3, because 2 into 0 plus 2 is 2. This is 0, 1, 2. And similarly at index 3, or let's say this is 8 and this is 9. Okay. So 2 into what is index number? Index 1 is 2. This is index 1. This is index 2. So 2 into 1 is 2 plus 1, 3. So at index 3, what you will put? 8. And at index 4, you will put 9. Now, if you want to know what is the parent of 9, then what do? You simply do 9 by 2. 9 minus 1 by 2. So 9 minus 1 is 8. 8 by 2 is, sorry, not 9 minus 1 by 2. Index minus 1 by 2. So what is the parent? So index of 9 is 4. So you do 4 minus 1 by 2. What is 4 minus 1? 4 minus 1 is 3. 3 by 2 is 1. So you'll get the parent. So the parent of 4 is at index 1, as well as the parent of 3 is at index 1. The parent of index 2 is at index 0. The parent of index 1 is at index 0. So you know that. So the way you store everything, represent a tree in array is with the help of indexes. So you consider that root node is at index 0 and the left child will be 2i plus 1 and the right child will be 2i plus 2. And you can always make that assumption to represent a particular tree in an array. Is it clear now? I hope it is clear now. Yeah, if you have any questions on this, then please ask. And you can unmute yourself and ask the question as well if you want. Cool. Considering this you understood, let's go on to the segmentary part again. Let me just clear this. Cool. So where were we? We were filling these indexes. Right. So now from fifth, what do you know? You can again break this down into 3 and 4. 3 and 4. And what do you store here? This was my index number 5. 2 into 5 plus 1, that is 11. At 11th index, you'll have value at 3. And 2 into 5 plus 2, which is 12. So at 12th index, you'll have the value stored for 4. At 11th index, you'll have the value stored for 3. Correct? And see, now 9th, because there is no child of this and this, nothing will be stored here. So this will become as 0 and 0. Even if you come here, this will be automatically 0. And this will be again, there is no child of 5 and 6 as well. So this will be again 0 and 0. So if you see, the size of the array which I have to create was of what size? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So basically the 14. So basically the size is 15, right? 0 to 14th index, because let's say if we would have 3 to 7 here, correct? Or 6 here, correct? Then we would have further, we would have break down this into 5 and 6, right? So in the worst case, there can be two child of this, right? As I mentioned, because it's a complete full binary tree. So the total number of elements by looking at this graph can be maximum 2 into something x. We need to figure out this x minus 1. And for now, this our x became what? Our x became 2 into 8 minus 1. Correct? We'll try to figure out how this 8 came, but just to explain you, that's how there will be some power of 2 here. I'll explain you why it is power of 2 here, and then we can discuss, because it's a binary tree, right? So there will be either 0 child or 2 child. So it will be always in the power of 2. Now what do? We start storing the data. So what do we have to store? So at 7th index, I need to store the data for 0th index. Correct? So what is the data of 0th index? That is 1. So I'll store what? 1 here. Correct? Now at 8th index, I need to store the data for index 1 in this array, which is equal to 3. So I'll store the data here. So this is done. This is done. Correct? Now let's see this one. So for 3, I have to store the data at 11th index. What is my third index? 0, 1, 2, 3, 7. So I'll store 7 here. Then similarly, at 12th index, I need to store the data for 4th index, which is 9. So I'll store 9 here. Okay. So this is done. This is done. Now what we need to do? We need to store the data for 0 to 1, sum of 0 to 1 at the index 3. What is the sum of 0 to 1? That is equal to 1 plus 3, 4. So 1 plus 3, 4, basically that will store at index number 3. So here we'll store 4. This is done. At index 4, you need to store the value of at index 2. So at index 4, what is the value at index 2? Which is 5. So we'll store 5 here. Then this is also done. Now from 3 to 4. 3 to 4 total sum is what? At index 11 and 12. 11 and 12 is 7 plus 9, 16. At what index? At index number 5. So I'll store 16. Now at index number 6, I need to store the value at index 5, which is equal to 11. So here I'll put. Okay. Now this is also done. This is also done. Now at 0 to 2, I need to store the value from 3 and the value at third index and fourth index ka sum. So we can take the sum of these two values, which is 9 at index number 1. Correct. And if you'll see what index number 1 represent, the sum from 0 to second index, which is 1 plus 3 plus 5. 5 plus 3, 8 plus 1. That's what we have stored. Similarly, at third to fifth index, I have to store the value from third index to fifth index at index number 2, which is equivalent to what? The sum at index 5 and the sum at like the value at index 5 and value at index 6, which is 16 plus 11, which is 27. And 27 will be stored at index number. And if you'll see from 3 to 5, total sum should be 27. So 11 plus 9, 20 plus 7, 27. Finally, you store everything at 0 to 5, which is equal to what? The value at index 1 plus value at index 2. Value at index 1 was what? 9 plus 27, 36. And if you calculate the sum of all these numbers, then finally what you'll get is 36. So that's how we create a segmentary array for a given particular given array. Okay. Now, I think the concept of bottom up and top down should be clear by now. If you have any questions or confusions till here, then feel free to ask. Please ask questions if you don't understand any of these approaches. I'll come on to the coding part. I'll come on to how I decided the size of the array and all those things. We'll discuss about that, but before we jump onto that, I want to make sure that you understood this much. So any questions? I'll give 30 seconds break. You can try to, or maybe a 1 minute break, and you can try to draw a similar tree by yourself, or try to go through this once. And if you have any doubts, then please ask. Because if you don't understand this, it will be very difficult for me to explain you the code of Segmentary.
Can you explain the
Prakar,
complexity part? I was not able to hear you that time.
Correct. So we haven't dealt with the complexity part yet. So let's try to understand the complexity later on. Well, I'll go through it. Don't worry.
The approaches which you explained earlier, I guess the way one way.
The above one?
Yeah, the first part, I lost that.
Okay. This one?
Yes, yeah.
So this is not related to Segmentary. So what didn't you understand there?
How exactly? I mean, I'm very new to this data structure, so I don't understand what exactly log O of log of n and how exactly you.
So you're talking about this one, right? The
Yeah.
update. Yeah.
Yeah.
So that's what I'm explaining. Please wait for it. I'll explain you. So what I told was that mentioned was that there is a way to do it in login. Now, how update and read works in login is still I have to explain you, right? So wait for it. But you understood the complexity here of this and this, right? Way one and way two.
No, that's what I was.
Okay. So see, for way one, if you're returning the sum from L to R, basically what you'll do, you'll start from this index and you'll keep on calculating the sum every time.
Yeah.
Correct? So in the worst case, you might end up iterating through the complete array. Correct?
Yeah.
Correct, to calculate the sum. So your sum will become what? Order of n. Correct?
Yes.
To read from here to here, if you have to calculate the sum, you will iterate through the complete array. So it will become order of n. Now, if you have to update something, correct? Then what will the complexity? You can directly in array, you can directly go to that index and update the value. Correct?
Yes.
So that becomes order of 1. Correct? So this is the read and update. Now, there is a second way. What do you do is you keep on calculating the sum till the end. So you keep 3. Then you do 3 plus 5, 8. 8 plus 4, 12. 12 plus 2, 22. 12 plus whatever. I've changed the array, I think. Or I made some mistake. 3 plus 5, 8 plus 4, 8 plus 4, 12 plus 2, 14 plus 8, 22. It is correct. So you keep this sum, correct? You calculate this sum once. Now, whenever you need to perform the read operation, then what do? You directly go to the, let's say you have to calculate from L to R. Let's say from this index to this index, correct? So what do? You have the total sum from this index till this index here stored, correct? you have the sum stored from here to here as well. If you deduct this sum from this sum, then the remaining sum will be this one. Correct?
Yeah.
So
Mhm.
that will take order of one operation because you know the indexes.
Yeah.
Correct? And if you have to update, now let's say if you change this 4 to 5, correct? Then you'll have to go and change, add +1 everywhere, right? Because you're maintaining sum here. Correct? You're maintaining the sum, right, of this complete array. So you'll have to update all these indexes by +1. So that will
Yeah.
become order of n. So overall complexity to update in this approach will be order of n. Correct?
Yeah.
Correct. So it's not either it will be, I mean, and if let's say there are m updates, correct,
Mhm.
then overall updates will be m into n. Correct.
Mhm.
And
Yeah.
if there are m writes, then overall approach in this case, if there are m writes, then it will be order of m into n, order of n, which will be m into n. Correct. So worst case it can be order of m into n. In both the cases it can be order of m into n, because you have n updates here, sorry, n read here, and you're doing that m times. Correct. So overall complexity in the worst case with both these approach can be order of n into n. So that's why we are trying to figure out if there is a better way to solve it. And there is a way to do it in order of m log n. And I haven't discussed the complexity how it is m log n, but the way to do it is with the help of segmentary. So now we are trying to understand how segmentary works. Correct.
Okay.
And then I'll explain you the complexity of the segmentary. Please wait for that. Okay.
Okay.
Any other questions? Any other questions before I move on?
Prakar, the way the index calculation is similar to heap, right? If I'm not wrong.
Yes, exactly. It is. It is very much similar.
Okay, thank you.
Okay. Okay. Assuming that everyone understood this much, let's try to understand how do you figure out the size of this given array. Okay. So we need to start. We have this array, right? We need to create. So this array is given to you, correct? And you need to create this array. But to create this array, first you need to know what is the size of this array. Okay. So let's try to figure out how to calculate the size of this array. Now see, if you'll see this is, as I mentioned, this is a complete binary tree, correct? This is a complete binary tree, correct? And if you'll see the height of a complete binary tree, if you know, is log n. In a complete binary tree, the height is log n. Why? Because every time you'll have n by 2, n by 2, and then you'll have n by 4, n by 4, n by 4, n by 4. So the ultimate height becomes what? Log n, right? In case of any complete binary tree. So if the height is log n, then the number of elements, or you can say, so the number of elements will be what? How many? 2. Wait, the height is log n here, right? So, okay, I'll explain. I think there is a simpler way to explain it instead of going into this. The way I'll explain you is this. So, how many leaf nodes are there? Can you tell me? How many leaf nodes are there? These are the leaf nodes, right? 1, 2, 3, 4, 5, 6. Correct. So, there are n leaf nodes, can I say? Correct. So, total number of internal nodes will be what? N minus 1. I think you should know this. These are the basics of tree. So, if you have n leaf nodes, then you'll have, can you please be on mute if you're not speaking? If you have n nodes, then the internal nodes in the tree will be n minus 1. So the total number of nodes are 2n minus 1. Correct. Now this n is trickier. I mean, you need to figure out this n. So the worst case, the height can be what? Your log n, correct? In a complete binary tree. So what I do is, instead of writing this as this, what do I do here? I write this as 2 into 2 to the power log of 2n minus 1. Correct. This becomes my what? This becomes my x. Can I say this is my x? Now, this is seal because it's a complete binary tree. If you just take n, then the problem is that you won't consider these indexes, but you have to consider these indexes as well. So what is log of n? This becomes my seal of log of n, and 2 to the power seal of log of n will be my number of nodes required. Let's try to understand this. Okay, so n is equal to 6 here. Okay, so what is log of n? Can anyone tell me what is log of 6?
It is 2 point something.
2 point something, correct? This is clear to everyone. So this is 2 point something, right? So if I take the seal of this, what it will become? It will become 3, correct? Now what is 2 to the power 3? 2 to the power 3 is 8. So 2 into 8 minus 1, which is equal to 15. Correct. So the size of my array was 15. If you see, the indexes are from 0 to 14. And that's what we derive from here as well, right? There is some 2 into x minus 1. Now this x we need to figure out. So the way we figure out x is with the help of the size of a given binary tree, complete binary tree. Because the number of nodes are n, the internal nodes will be n minus 1. Total number of nodes will become 2 into n minus 1. Now this n can be written as log of 2 to, so this can be written, n can be written as n log of 2 and log of 2 is 1, and then you can replace these two. So this will be replaced like this, log 2n, this will become 2, correct? This can be written, this is the same thing, these and these are the same thing, correct? Now because we know that n is not a multiple of 2, n is not a multiple of 2, right? So we can either make n as a multiple of 2, or what we can do is we can always take a seal. If we take not a multiple of power of 2. So if we take a seal, then automatically whatever number we'll get, if we take a seal, it will become multiple. It will be in the power of 2 to the power something, correct? So if we take a seal and then do 2 to the power something, then this will give me the number of worst case nodes which this binary tree can handle at this height, correct? So we will know that the number of the array of the segmentary, the size of the array of the segmentary which we need to create. Okay. Is it clear to everyone? Okay, if you didn't understand this completely, I think it should be fine. What you can understand is simply that there are 2 into n minus 1 nodes, okay, correct? And sorry, 2, you can assume that there is 2 into x minus 1 nodes in a given binary tree. So there is any binary tree, complete binary tree, you create this complete binary tree, right? You'll have 2 into x minus 1 nodes. Now what is this x? So this x is always a multiple of 2. So let's say there is 1 node in a complete binary tree. So this will become what? 2 into 1, 2 to the power 1. 2 into 1 minus, sorry, 2 into 0. 2 to the power 0 is 1. So 2 into 1 minus 1. So 1 node. Now let's say you have 2 nodes, 3 nodes. A complete binary tree again, right? Or full binary tree, sorry. So you'll have 0, 1, 2, 3 nodes. So this will become 2 into 2 to the power 1 minus 1, which is equal to 3. Similarly, if you have of size 1 of level 3, then this will become what? How many nodes you have? 1, 2, 3, 4, 5, 6, 7. This will become 2 into 2 to the power 2 minus 1. So 2 to the power 2 is 4, into 2 is 8, 8 minus 1 is equal to 7. So we need to figure out the best x. Now how to figure out this x? You know the number of nodes you have, but that is not in multiple of, it's not in power of 2. So what do is you do the log of this, okay, and then do the seal of this, and then put 2 to the, so that it becomes in the multiple of 2. That's how you create the size of your given segmentary array. Okay, so I hope this much is also clear. Now let's try to understand the update part. Okay, now this much is already given to you. Okay, and then after that we'll talk about the complexity as well. But first we'll try to understand the update part, how update works here. Okay, so let's say now you decided to change the value of. So let me try to clean this up and let's try to draw a. You have the segmentary. Okay, let it be here only. It's okay. It should be fine. Let's say you plan to update this 9 to 5. Correct. So the index number 4 is affected. Correct. So definitely what all indexes should be affected, we'll try. I mean, there will be few values which will change in this array because this 9 was updated to 5. So we have subtracted, we have decreased the value at this index by 4. So definitely this will affect all the other indexes as well. So what do? When you come here at 0 to 5, you see that the 4th index is a part of this. So you simply subtract the 4 from here. So this will become what? 36 minus 4, which is equal to 32. Then is this a part, is this index contains my 4th index? No, it doesn't contain, because 4th index was changed, right? Here we are storing the data from 0 to 2, but this one contains the 4th index. So the value at this should also be decreased by 4. So what is the index? Index number 2. So we'll decrease it by 4. So this will become 23. And then again, we'll go down and check. Now this won't be affected because this was just the index 5, but this will be affected. So what index was it? Index number 5 from 3 to 4. This will be affected. We'll subtract 4 from here. So this will become what? Instead of 16, this will become, instead of 16, this will become what? 12. Correct. Now once this is also done, then you check whether this is affected. No, this won't be affected, but this will be affected. So index 4 is affected, as you mentioned. The value of index 4 is changed from, so index 4 of this and index 12 of the given of the segmentary array. So the value will be decreased by 4. So earlier it was 9, it will become what? 5 now. And that is what we have to update it to. This became 5. Now see, you just to update a value, you just followed one path. Either you went here, then you took a decision to go here, then you took a decision to go here. Now, as I mentioned, if it's a complete binary tree, then the worst case, complete binary tree is always balanced. So in the worst case, what happens is that you will end up traversing only log n nodes and not all the nodes to update a value. So basically what you did, you just updated this and this. So this is my login. So can I say that update becomes my login? One update will be equal to a login. If this is clear, then we'll come on to the sum part. If you have any questions here, then please ask. If you want me to explain it you with the help of other example, then I can do that.
Prakar, can you explain one more time the update part?
Okay, let's take
Individual.
update of some other index. Let's say I have to update 11 to 18. So we are increasing the value by 7, correct? So this 5th index is affected. Here the value is increased by 7 and 5th index is affected and the value is increased by 7. So whatever array segmentary array we have, if there is a 5th index involved in that array, at that index, then we need to update the value. We need to add 7 there, correct? So we start with this index. Was 5 part of this index? Yes, it was, because it was from 0 to 5. So 5th index was part of it. So we'll increase the value by 7. So 32 will become what? Now 39. Okay. Now what do? You check the left child and the right child. What is left child? Left child contain the value from 0 to 2. Right child contain value from 3 to 5. So which one will be affected because the 5th index is changed? This right child will be affected and the value should be increased by 7. Where was that value? At index 2. At index 2 will increase it by 7. So this will become what? This will become 30. Correct. Now again we check which index, either left index or right index can be affected because of the change in the index number value at index number 5. So this is from 3 to 4. This won't be affected, but this is just for index 5. So this will be definitely affected. So what is the index here in the segmentary array? That is index number 6. So we'll increase the value by 7. So this will become what? 19, 12 plus 7. So okay, at index number 6 we had 12. Okay. Sorry, at index number 5, 6. Okay, we had 12 only, right? Something, no, it's fine. So this will be affected by 7. So 11 will become, 12 will become what? It is fine only, right? I think it should be fine. This will become 19. Now, if you'll see here, that sum from third to fifth index. What is the third index? Third index value at index 3 was 7 plus 5 plus 19. What is 19 plus 5? Okay, I made a mistake. I think it was 11 here. And I mentioned it 12 here. So it should be 11. So this will become what? 18. Correct? Because I changed 11 to 18. By mistake, I wrote it 12 here, but it should be 18. Correct. So here it is 18. 18 plus 5 is what? 23 plus 7, 23 to 5, it should contain 20. 3 to 5, it contains, sorry, 30. It contains 30. 18 plus 5 is 23 plus 7 is 30. It is 30. And if you add all these values, 18 plus 5 is 23 plus 7, 30 plus 5, 35 plus 1 plus 3, 35 plus 3, 38 plus 1, 39. Here you will see the value is 39. So the path you are following just to update this index is this and this. Correct. So worst case, it can go to one of this path, either this or this or this or this or this or this. So the height in a complete binary tree for a given tree is log n, log of m, whatever is the number of elements you have, m. Here the size is this m, right? Log of m. So overall complexity will become what? Log m. And which is better than the one which we discussed earlier. Correct. So yeah, that's how it works. I should increase sum by 2. Why should I increase sum by 2? Only this index is affected, right? So only this will be affected once, this will be affected once. So it should not be incremented twice. It should be incremented only once. Okay, any other questions or confusion so far if you have?
No, Prakar.
Okay, cool. Let's try to understand the sum part now. Is it clear now or not to everyone? If not, then please. Oh shit, what? Shit, man. What's here? Okay, cool. Okay, got it. Cool. Let's try to understand the sum part now. Let's say you have to calculate the sum from index number 1 to index number 5. Then how do you approach this problem? So see, this one contains 0. It contains the sum from 0 to 5. Correct. So definitely you can't take this one because it contains from 0 to 5. Now you come and here it contains 3 to 5. So basically whatever, so now you know that from 3 to 5, whatever is sum is here, I can return that sum directly. I don't need to go and calculate for 3, 4, 5 separately. Now you just need to calculate it for 1 and 2. So you will come here. It contains from 0 to 2. So again, you can't take this one because it contains from 0 to 2. So again, you will go here as well as here. This one contains only for 2. So you'll return from here. And this one contain again from 0 to 1. So you'll go here down and you will check what is the sum at 1. You'll return this sum, this sum. So for 1, you have returned. For 2, you have returned. For 3 and 5, you didn't go to the end of the tree. You directly have this sum already pre-calculated. You used that sum. So basically, it will, the sum, whatever is returned from here, here, and here will be added up and will return the total sum. Let's say if you want to do it for a 0 to 2. So what do? You start from here. Okay, you check 0 to 5. No, I can't consider this because it contains till 5 from 0. You go here. It contains from 0 to 2. Directly you return the sum. You don't need to go and calculate it again because you have already updated the value here. If there is any update made here. So basically from 0 to 2, whatever will be value will be returned to your, will be returned as your answer. Yeah, we can talk about this separately later on. Cool. I hope this is clear to everyone, this much part. Do you have any confusion so far? If not, then we'll jump onto the code. I mean, and believe me, it's not difficult at all. It's very easy. As long as you understand this, uh, I think it should be fairly simple to write the code as well. If you have any questions or confusion, then please ask. I'll wait for like a minute or so, and then I'll start again. Meanwhile, you can revise the whatever I've gone through right now, and then we can see like how to write the code for the same problem.
We lost your screen, Prakar.
Yeah. Oh, okay. Okay. So sorry. Just a minute. Can you see it again? Is it visible now? Okay, cool.
Prakar, one question.
Sure.
When we don't know the size of the array, how many elements that we have present,
No, that
so
won't be the case ever, right? You will know the
okay,
size of the array. This array size will be
okay,
always given to you. Correct. How you will create
okay,
otherwise. This array size will always be there.
okay. So we will know the size of the array, then
Create the
then we will be able to construct the tree like this.
got it. Yep. Exactly.
Okay, okay, got it. So it can go to uh, any level, any depth of level.
Yeah,
Means let's
exactly.
say if
Yeah.
okay, and also it don't need to be arrayed, don't need to be sorted or anything as such.
Nothing. I didn't talk
Oh,
about any sort here, right? It
yeah,
was
yeah.
just
You
an
did not
example
talk
of
about it. Okay, okay,
if you sort the array, then it doesn't make sense, right? Because you need to return the sum from L to R. So your L and R will change in that case, left index and the right index. So you can't sort the array given array. Correct.
okay. Got it.
Okay. Cool. So should we proceed from here, or like if you have any other doubts, then please ask. Otherwise, I'll proceed from
So space complexity wise, it will be like O of n because we
here.
are
No, it won't be
storing.
O of n. It will be more than O of n, right? If you see the spaces 2 into whatever we have created, right? 2 into x minus 1, that will be your space, correct?
Okay,
Then next is your 2 to the power log n, seal of log n, correct? So that will be your space. Definitely, it's not order of n, right? Because we are creating some extra nodes to store the data. So it's definitely not order of n. Okay.
but in this example, whatever you have explained, like it has like 8 nodes, right? I think 1, 2, 3,
No, it has
4,
more than
5,
8
7.
nodes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 nodes were there, right? We took the
Okay,
size, 15 is the size which we calculated, right? So the extra space is 2 into, so basically your complexity, space complexity is 2 into 2 to the power seal of log n minus 1. That is your space complexity. Okay, cool. Assuming like everyone understood uh, the theory part, we can jump onto the code part. Let me open the collaborate link. Shut this down. So my screen is visible to everyone, right?
yes, Prakar.
Space std. I'll write it in C++ again. You can easily convert it into Java. Java is always simpler than C++. And if you have any questions while I'm writing the code, you can ask related to Java. Okay, let's have int main. Let's have int array. This is the array given to you. Okay, so let's take some array, some values like 2, 1, 4, 3, 6, 8, 5, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, that should be enough. Okay, now what do? We need to calculate the size of our segmentary array. So can I call it as segmentary STARR? Let's call it as STARR. So we need to create STARR. So first we'll do what? Int size equal to. First we need to calculate the size. So this will become what? 2 into seal of power of, sorry, log of. There's a log function directly, as far as I remember. Log of, I don't know if, I think there is a log function. 2 into, so okay, wait, I have to do log of n, right? And then seal of it I need to do, and I need to do this on power of 2 comma this. Seal of log n minus 1. Yeah. So this is the one which I explained you. This is my x. This is my 2 into x minus 1. Like, I don't remember if log is a function directly or not. If it is not, then there should be a basic function log 2n or something. I think it's log 2n. I don't remember it, but you can check it. You'll easily find it. And then STRR will become what? Of size. And everything can be initialized with 0. Or you can run a loop and initialize everything by 0. I'm not doing all those things. Those are very simple. Now we have multiple queries. So first we need to create segmentary. So what do? We do call create. Sorry, just a minute. We call create segmentary. This is my creation method. Okay. And let's try to see what all do we need in our segmentary. So we definitely need the current array. We need the STARR segmentary array. Then we need the index, starting index, the number of elements which we have. So size of this array minus 1. So let's assume that we know the size 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 1, 0 to 7, comma, and then you have some index starting 0. This is my, which index? This is my, as I mentioned earlier as well, this is my index of a segmentary array. Seg3 array. Whatever this has happened. What is this? Okay. Yeah, you can. Okay, that should be fine, man. I mean, you can consider all these things. ARR dot length you can do. Yeah, whatever. Now this is not vector. You can't directly do this, but fine. You can calculate this n, right, by yourself. So let's say the array size is given to you. Int n is given to you. You created array. Take all these input by yourself. N equal to 7. I'm ignoring all these small things because this you can figure out by your own. This will be n minus 1 then. Correct. And this is my last index of ARR. And this index, this represents my first index of ARR. Okay. Cool. So this is create segmentary. Now let's try to fill the create segmentary method. Okay. So what do? We do int create segmentary, and what do? We write here int ARR, int STARR, and sorry, STARR, comma end starting index of array, start ending index of array, and you can starting index of given array. So you can SS start. This is not my segmentary. Okay, this is my normal array index. So we can call it as ST, and then we can call it as end, and then we can call it as the last one int end, int ST, int end, and then you have what int segmentary index. So I'm representing it by SI. Hope this much is clear. Correct. Now what do we do here? So what do? Always we check what is the current. So basically, if you remember here, till what time do we keep on going? Till the time my starting and end doesn't become equal, I'll keep on going down, right? I'll keep on calculating the mid. So what I'll do, if st double equal to end, then what can I do? I can write, yes, someone was saying something, st of ARR of SI equal to ARR of ST, I can say, correct? And then I have to return some value. So I'll return whatever is value at my ARR of ST. Or I can return the value at ST ARR of SI. So this is the value return. Now if the index are not equal, then what do we do? We calculate mid. Int mid equal to, let's say we have get mid function, correct? What do we do here? Get mid, we pass starting index, we pass end index. Let's try to write the get mid, which should be fairly simple. Int get mid, correct? And what do we do here? We just do return what st plus se minus what we got end st comma end, correct? End minus st by 2. This also you can do st plus end by 2 as well. It's the same thing basically, correct? So this we have figured out, and this will be my integer, so it will automatically return you the floor of this. You come here, you figure out the mid, and then once you know the mid, what do? You do int STARR of why int STARR of, and this is what you return. STARR of SI you need to calculate equal to, you call create segmentary, you do ARR comma STARR comma ST comma end will become my mid comma this will become what 2 into SI plus 1 as we discussed. This is my first index plus whatever sum is returned for the second one as well. Create 3 segment, correct? And what do we have here? We have ARR comma ST ARR comma this will become what mid plus 1 comma end comma 2 into SI plus 2, and we'll return this. Finally, this will be created. Cool. Time for questions. So this is my create segment tree. Some I can make it just to clear that we are creating the sum. Okay. This is my create segmentary sum. Any questions you have here, then feel free to ask. Otherwise, I'll try to create the other ones as well. We need to create one for update and one for calculating the sum as well, right? So we'll jump onto that once this is clear. Try to understand the code. If you have any question, then please ask. I'll wait for a minute.
So 2 into SI plus 1 will create the left subtree, and 2 into SI plus 2 will create the right subtree.
Exactly. Yes.
Okay. Okay. One question. When we are calculating the mid, generally we say start plus n by 2, right?
It doesn't make a
It is the
difference.
same thing. Okay. Okay.
The
Fine. I
maths,
was
you
just thinking like, does it has any better approach? I was thinking just like that.
calculate. It's simple maths.
Okay.
Okay. Okay, I'll wait for 30 more seconds maybe.
When we calculate the right subtree, do we actually make use of a start value at any point of time?
Which start value? This one.
STARR. Do we actually make use of it, or
We are actually putting this value here, right?
okay?
We are filling this array, right? We have to fill this array. This is my STAR, right? This is a segmentary array.
Okay.
So
Okay.
calculating it, and then finally I'm filling it here. Here
Okay.
we have filled it, and here we are filling it.
Okay. So it will calculate the total sum and it will return for the complete array.
Correct. Not for the complete array, from that index, whatever is stored till here. Ultimately, like from 3 to 4, it will return 10. Then
Okay.
you can use that in calculating 3 to 5 as well. With 3 to 4 plus 5, this will give you 3 to 4, 3, 4, 5 sum. That's how it works.
Okay. I mean, it all depends like what start and end index we pass it. If I'm right, if I understood correctly.
Yeah, but that is something which is calculated by the number of indexes, the size of the array, right?
Okay. So in this case, then it will return for the complete 0 to 5 as per the diagram. It will.
Final will be 0 to 5. Final when it will be returned, but
Okay.
it's a recursion, right? So we are filling multiple.
Yeah. Makes sense.
Any other questions? If you have. Cool. So assuming that create segment tree is clear to everyone, let's try to figure out how can you do the. Okay, I'll do one thing. Can you try to write the code for the other part, or try to write the one for updating? So try to. I want to want you to try it by yourself, and meanwhile I'll write the code here and then explain how it works. So if you can do it for update by yourself, what all parameters you'll need, how to do it. Let's try to write it for update. So you have create segmentary, then you have update segmentary. So what all do you take? You take the index, what you want to update. So let's say index number is 5, and what value you need to update. So this becomes my index to be updated. Value to be updated. So let's say index number 5, I need to update. I need to update it to 10. I need to update it to. So how do you do it? So let's write try to write the code for update tree. So we have int update tree, right? And what do you do? We have int index. We also need to have the array and the size of the array. At least those things are required, right? So ARR we have, ARR we have, correct? And size of the array we have, which is n minus 1. That's it. Correct. And you can have the size of the strr as well, but it is not required. Let's see if we can do it with the help of these indexes only. So we have what? We have int ARR, we have int sorry, this is an array. This is an int ARR, int size, comma int index, comma int value. Okay. We might have few conditions like if index is less than size less than 0 and end index is greater than -1, then update. We don't need to return anything, we just void. So you can't update indexes greater than size -1 is equal to size -1, then it should be fine, right? Yes. So what do we do here? We say just simply return, because we can't do anything here, right? We return. What do we do now? So we need to update the value, right? So we calculate the value which what is the difference we need to update. So let's say we do int diff equal to what? So diff will become whatever is the ARR of index minus, sorry, the diff will be positive or negative. It depends. So it will become a value minus ARR of index. It can be negative or positive. So we need to update. Let's say this is big or this is less. So we'll have to update, add the diff every time. So what do we do? Once we calculate the diff, then we call update util or recur method. We can have a new method, update recur, and we'll pass ARR, we'll pass strr, we'll pass starting index, will pass n minus size -1, that is the end index. Sorry, if I'm passing n -1 here, then it will be greater than equal to, and it will be equal to size. Is greater than size, sorry. And here also, if it will be, if I'm
Interesting question.
If I'm passing n -1, then here it will be size again. Correct. Correct. And then what we have? We have the diff, and then the starting index. Starting index of strr, which is equal to what? Which is equal to your 0. Correct. So now let's try to write update recur method. So what do? You simply return void, you do update recur, and then what do you have? Int ARR, comma int strr, comma, sorry, these are all arrays, correct? These are all arrays. Now what do? You have this, you have this, you have int st, comma int, and comma int si, int diff, comma int si. These are the parameters which you are passing. Correct. Now what do we do here? So we need to calculate. So first thing is we need to definitely update at whatever index you are standing, because this is the index at which you are standing, right? So root node will definitely be modified. So what do? We simply say strr of si plus equal to def. Correct. So we have added the def in the current str. Now what do we do? Find mid. Int mid equal to get mid with the help of what? St comma end. St comma end. So I'll get the start, end, and mid. Now if, what do we need to do? If mid is, oh, okay, I haven't taken the index which we need to modify here. So we've taken 0 size def, we'll have to pass the index as well, right? Which has to be modified, comma index, comma def. So here I'll take end, index as well, correct? Comma int def. If mid is greater than equal to, sorry, mid is greater than or equal to index, then what do? We simply do, we call what? Update tree recur with update tree recur, because see here, if it is greater than equal to index, means that it is on the left side. Basically you have to modify this tree, correct? So what do? You call update tree recur with arr comma st arr comma st comma end comma index comma def comma 2 into si plus 1, correct? If this is not the case, that means mid is bigger, mid is smaller than the current index. That means you have to go on the right side. So we'll call update recur. We'll call update recur, and we'll pass arr comma arr comma st comma end comma. Sorry, this will not be end, right? This will be mid. This will be mid plus 1, and this will be end comma index comma def comma 2 into si plus 2, correct? So we'll go to the right hand side of the tree. Now we are going to the right hand side of the tree. We'll keep on doing that. And when do we need to stop? We need to stop where si becomes equal, st double equals to end. So what do we write here? We write if st double equals to end. That means that we are on the index where we need to go. So what we'll do, we'll simply strr of index or strr of si equal to strr of si equal to what? Plus equal to def. Okay. So plus equal to def, and then we'll return, correct? And or if you don't want to do this, then simply you can remove this condition as well, because your mid will start after a time. Your mid will be same index, sorry, mid will become lesser. So you can remove this, and maybe you can do it here itself. So what you can, it will be trickier because you don't know the si. So you'll have to do it here actually. Sorry.
Prakar, one small question.
Just give me a minute.
Sure.
Yes, tell me.
How are we able to say if mid greater than index, go to the left subtree? Yeah.
So see, you have this is your mid, right? So 0 to 5. Let's say you have to update which index. You have to index update here. Let's consider this example. Let's say you have to update index number 4, correct? Or index number 1, correct? Now if 0 to 5 is the total size of the array, right? These are the indexes present in our array. So if I take the mid, it is from 0 to 2, correct? If it is from 0 to 2, then I have to go in the left subtree for sure, because that's where the index 1, the sum of the index 1 is kept, right? I mean, the indexes having that sum, considering 1 as a part of it, will be there in these indexes, right? So we'll go to the left tree. So because 1 is mid is greater than equal to. So because mid is 2, mid will be 2. So 2 is greater than equal to 1. Correct? That's why we are going on the left tree. Now again we take out the mid. So what is mid? 0 plus 2 by 2, that is equal to 1. So if it is 1, then what do? We again, is it greater than equal to the current index or not? So 0 plus 2 by 2 is 2. 0 plus 2 by 2 is 1, and 1 is greater than equal to 1. So you get the left subtree. If you go to the left subtree, that's where your 1 will come. Your ST will be what? 1, and will be 1. 1 and 1 will become equal, and then you'll end up updating the value of this, updating the value of this, and updating the value of this. And that's what you need in your given question. So this will be 0 to 1. Sorry, not 1. 0 to 1, right? Again, if you do 0 plus 1 by 2, that will become 0. So your mid is 0. Your current node is 1, correct? Or the value to be updated index is 1. So you go to the right check. So, and you end up updating this one as well. So this is updated, this is updated, this is updated, and this is updated. And that's what you want when you update one from something to something. So that's why for sure we can say that whether if the mid is greater than the index to be updated, then you need to go left, greater than equal to. If not, then you need to go right. Is it clear? Or still not clear?
It's clear.
Okay.
No, it's clear.
Cool. Any other questions on update part before I move on to the get some part? Okay. I'll wait for like 2-3 minutes. Try to go through the complete code once and try to see if you have any doubt. Let's go so create parent tree. Some you would have already checked. Check the update tree, update part completely. If I have missed something, then please let me know. Okay. Any questions? Okay, cool. So I'll assume that there are no further questions on this. So we'll get onto the sum part. Correct? How to calculate the sum. Correct. So let's try to see the sum part as well now. So what do you do to calculate the sum? So there will be index given to you from where till where you need to calculate the sum. Correct? So we'll try to see if we can calculate the sum. So say calculate sum is the next. I'm going to you. So what you have ARR, you have STARR, and then you have n-1. This is your index given to you, and then you have what from left to right. So this represents left and right indexes for which we need to calculate this. So we'll write this and calculate sum, and then what all we got? We got int ARR, we got int STARR, we got int size, int left index, int right index, and that's it. Correct. So there are a few basic checks we can do. If left is greater than equal to 0 and if left is less than 0, then it's a problem, right? We can't do it. Or right is greater than size, or left is greater than right, then we can simply return 0 because there won't be any. This is not a valid input. Assuming that the valid input will be there, we need to write the approach for that. So let's say we can write calculate sum recur, and what all we are passing ARR, comma st ARR, comma 0th index, comma size, comma left, comma right, comma whatever is the index of the, this is 0, starting index of st ARR. Correct. So let's try to fill this. So can I call it as calculate sum recur? So I have to return the response of calculate sum. So I'll do int calculate sum recur, and what all I have got, int ARR, comma int st ARR, comma int. So this I was doing the st, comma int end, comma int left, comma int right, comma int sa. These are the things which I have. Correct. Now we need to calculate the sum. Now let's try to think through it properly, how to calculate the sum. So see, there are few basics conditions which we can write for sure. If my st is less than, if my st is greater than equal to left and end, if my end is less than equal to right. Okay. That means that this subpart, so let's take the example here. That will be easier for me to explain. So let's say this is the array given to you. This is the size of the array. Okay. Now if you have to, this is my current starting st, this is my, sorry, this is my st, this is my, sorry, this is my end, this is my end, and then there can be this something here, because we have this recursion, right? This st and end will change on the basis of mid, and let's say my left was here somewhere, correct, and right was here somewhere. So basically, if I need to return the sum from here till here, I need to return the sum of this, and sum of this, can I say? Okay. So if this left is less than equal to st, and n, right is greater than equal to n, that means that this complete sum has to be returned for sure. Correct. So that's what I've written here. So what I'll do is I'll return, in that case, whatever is the sum. So that is st ARR of s. Okay. Now, if that is not the case, then see, the other case could be that left and right completely exist inside these st. So we'll have to figure out where exactly we need to go, whether we need to go left or we need to go right, or we need to go, and it can happen that this is present somewhere here as well. So whether we need to go here, we need to go here. Basically, this is my start, this is my end. Sorry, st and end will be completely present here. So assume this, st is here, end is here, and somewhere mid is here. Correct. Now my left is here and right is here. Correct. So I just need to go on to the left part if my mid is greater than right. So if my mid is greater than right, then I just need to go to the left part, correct? So can I write here, first I'll do int mid equal to get mid on the basis of st comma, correct? Now, as per this, if my mid is greater than equal to, if my mid is greater than equal to, mid is greater than equal to right, correct? That means that mid is greater than or equal to right. That means that I have to definitely go on the left hand side. So what I'm doing is I'll call return calculate some recur. I'll return this and I'll call what ARR comma st ARR comma st comma end will become what my mid comma, sorry, I'm going on to the left side, correct? Yeah, so this will become my mid and then you have left comma right comma si will become what, 2 into si plus 1 because I'm going into the left side. Now what if my left is greater than mid? Then definitely I need to go on to this side, correct? Without even thinking, my mid is greater than, mid is less than left. So basically everything is on present on the right hand side. So what I'll do, I'll write the second condition as if mid is less than equal to left, then definitely I need to go on to the right hand side. So I'll do this, I'll do this, and this will become what, my mid, sorry, it should be less than equal, less than left. Mid is less than left because see, I'm not considering equal to ever, right? So if it is less than left, then only I need to go on to the right hand side, correct? If it is not less than, then we might need to take the value of this index because left can be at the mid, right? If I go to right, then I won't consider this because my mid is always like the sum is stored from 0 to mid in a given index, correct? So if mid is less than left, then only calculate some recur. I need to go just on the right hand side. So I'll do mid plus 1 to end, mid plus 1 to end left, and this will become what, 2 into si plus 2. And if that is not the case, if this is not the case, then what I need to do is that your left is here somewhere, right is here somewhere, and mid is in between somewhere. So you need to go on to the left child as well as you need to go on to the right child, correct? So what do you do here is you say if there is no if required, so basically return, you do calculate sum of this plus calculate sum of this, and this will become mid to left. Now let's try to take an example and try to, I might have made some small mistake, not sure. So if st is less than equal to, it is completely inbound, then I don't need to worry about it. And if it is not completely inbound, should I, I'm just thinking if I need to change this right to mid or not. Because you're left and right. Now right is this. So this, correct, and with this. Correct. Let's take an example and try to understand, right? So let's say if you want to take out, let's take the same example. Okay, we'll try to see for each and every. Let's say you have to take out the sum for 0 to 5. So if you come from 0 to 5, st will be 0, end will be 5, left will be 0, end will be, right will be 5. st is greater than equal to left. Yes, it is greater than. End is less than equal to right. Yes. So str of si will return, which is will return 0 to 5, whatever is the sum. Now let's say if I want to calculate from 0 to 1, then what happens? So left is 0, right is 1, st is 0, end is 5. So this won't be satisfied. correct? Because ST is greater than left and then end is less than right. What is my end? End is 5, right is 1. So this is not satisfied. We find the mid. Mid is equal to 2. Now if mid is greater than equal to right, what is mid? Mid is 2, right is 1. 2 is greater than equal to right? No, it is not. 2 is greater than equal to 1. Yes, correct. It is. So we'll go on to the left side. So my ST will be remain 0, mid will become what? 2, left is 0, right is 1. So we come to 0 to 1. Now again, is this satisfied? What is end? End is still 2, correct? And right is 1. So this is not satisfied. We again take the mid. So what is my mid now? Mid will be 0 plus 2 by 2, which is equal to 1. Correct? So we come to 1. Now what is my mid? Mid equal to 1 and right equal to mid equal to 1. And what is my right? Right is also equal to 1. So mid is greater than equal to right? Yes, it is. So we go to the left hand side. So we go to the left hand side from 0 to, so my mid will become 1, ST will become 0, left is 0, right is 1. So if you call recursion, end will become 1. So this is 0, this is 1. So this is satisfied, and from 0 to 1, the answer will be returned. Correct? Now let's consider that we had 2 as well. Correct? So what happens here? This will be this. So right will be so from 0 to 2. Okay, let's try to for 1 to 2. What happens for 1 to 2? 0 to 2, it will be directly returned here itself. So from 1 to 2, what happens, right? Or let's take from 1 to make it more 1 to 4. Let's check if it works for 1 to 4 or not. So left is 1, right is 4, ST is 0, end is 5. ST is what? 0 is greater than equal to left. ST is 0, left is 1. So it is not greater. So this will be satisfied. So we'll calculate the mid. What is my mid? Mid is 2. Mid is greater than equal to right. What is right? Right is 4. No, it is not. Then we'll check this. Mid is less than left. What is mid? Mid is 2. Is less than left. Left is 1. No, it is not. So we call this calculate sum here. And what will happen? My left will become wet. Left will still remain what? 1. Right will remain what? 4. And now mid will, ST will become what? 0. And mid will be 2. Correct. And similarly, mid plus 1 will be 2, 3, and mid plus up to end will be 5. So now we first go to 0 to 2. So less ST is equal to what? ST is equal to 0, and left is greater than equal to left. What is my left? Left is my 1. ST is not, no, it is not. And end is less, so this won't be satisfied. So again we calculate the mid. So what is my mid? My mid is 1 in this case. So we'll go from 1 here. We'll check mid is greater. So this mid is greater than right. What is my mid? Mid is 1. What is my right? Right is 4. 1 is greater than equal to 4. Yes, 1 is greater than equal to 4. Wait, what is my mid? Wait.
False, right? 1 is greater than or equal to 4, false.
1 is greater than equal to false. 4. So that is false. Then 1 is less than mid. So 1 is less than left. What is left? Left is 0. So this is again false. So we'll again call to calculate sum recur, and we'll again break down 0 to 2 into 0 to 1. Sorry, 0 to 1 we have already break down. We will go to 1 and 0 to 1 and 2. So we'll break down this into 0 to 1 and 2. Correct. So now my end will become 1, ST will become 0. Now ST is greater than equal to left. ST is what? 0. Is greater than equal to left. No, it is not. Left is 1. So again we find the mid. Mid is what? Mid is my 0. So mid is greater than equal to right. Mid is 0 greater than equal to right. 0 is not greater than right. Correct. So this won't go. So 0 is less than left. Yes, it is less than left. So 0 is less than 1. So we'll go to the calculate sum recur. So basically you will come to the first index and you will return whatever is here, because you will call left here. Correct. you'll call this, and what will happen? This will become 2 into SI plus 2 and mid plus 1 and, right? So this will become mid plus 1 will be what? End was 1, mid plus 1 is also 1, correct? So 1 and 1. So what now? ST is 1, end is also 1, correct? Left is 1 and right is 4. So this will be satisfied and you will end up returning the answer at index 1. So whatever is at index 1 will be returned here. So 3 will be returned from there. Then what happens? Again, there was a right as well, right? So we didn't consider the second part. So for that, for 2 it will be returned from, similarly for 2 it will be returned from here. And then there was a right part when we broke down 1 to 4 from 0 to 2 and 3 to 5. So we'll go to the 3 to 5 part as well with the help of this recursion. And again, you will check, so you will come to 3 to 4 and then finally you'll be able to return for 3 to 4. So this approach will always work. So that is the solution. It's a very simple thing, right? You just create, I just created 4 data points with the help of a diagram. What happens if ST is complete, ST is and end is completely inside left and right, correct? Or is touching left and right. Then you return complete ST end. If left and right is on the right of mid, that means that they are here, correct? That means you need to go on the right hand side. So you go on to the left hand side, right hand side. If it is completely on the left hand side, then you have to go on to the left hand side. So you go on to the left hand side. Then there is one case where mid is between left and right. So you need to go in the left as well as in the right direction. So I went in the left here in this case, let's say. So there are 4 cases. One is basically this is my starting, this is my end, and L and R are lying in between. So basically whatever is L is here, R is here, correct? This is my ST, this is my end. So basically ST and end are completely lying between L and R. So you can directly return this sum. There will be some other sum which you need this and this as well, but you can return this sum and finally recursion will take care of calculating this and this as well. Then there is another case where ST is here, end is here, correct? Left is here, right is here, and mid is here. That means that definitely you need to calculate this one. So you need to come onto the left of mid. Then there is another case where ST is here, end is here, mid is here, correct? Left is here, right is here. So definitely you need to go onto the right hand side to calculate this. Then there is another case where ST is here, end is here, left is here, right is here, mid is here. Then what you need to do? You need to go here as well as here. Right? So that's what we did. These are all cases. These are all the cases which we have. So we are able to calculate with the help of this. Is it clear to everyone like what I did?
When you say, Prakar, when you say ST, it is start index, right?
Starting index, yes, and end index, yes. ST is the index of the this particular array. Okay. So yes, that is all I have for segmentary for today. If you don't have any questions, then we can stop it here. I'll share the code with you. There might be some small syntax errors which you can correct by yourself, but
can you share the link in the chat?
The link.
Any specific interview questions on this, or is it a straightforward question that can be asked, Prakar?
I can discuss about few of the questions tomorrow on Segmentary.
Okay.
I've shared the link. I will share the code with Aditya and he can share it with you. Okay, great. Thanks a lot. Thanks all of you for joining. Hope you understood few things about Segmentary. I know it's difficult, but eventually once you will try to understand it by yourself now, it will become easier and yeah, I mean, Segmentary is not very frequently asked in interviews, but there are few companies which ask questions which are related to Segmentary. So it's always better to know how it works, at least the approach.
Okay. Thanks, Prakar. It's a nice session.
Bye. Just end the meeting.